So for your practical of density gradient identification, I am having 3 samples in which few are the petrol and one is diesel and another is the adulterated. So by this you can understand these are kept in the refrigerator and one of these is petrol. So you can see the consistency. So this would be probably the petrol, and this one is light in color and it is freezed. You can see at the bottom, as I kept it in the refrigerator, at the bottom it is freezed. And this one would be the diesel. And this third one, this one is slightly at the bottom, I can see some freezing, that means it is frozen, and at the top there is a petrol, so it is a semi in the nature. So by seeing the nature and consistency of the fuels and itself, we can identify which one is what. So why I kept it in refrigerator is to, while determining the density of the fuel, we need to identify its temperature. That means we have to maintain the temperature at 15 degrees Celsius. So if you check your practical manual, at that time you can observe that you have to do this analysis in the 15 degrees Celsius. Okay. So these are the samples, and the things in which we have to do the examination is the cylindrical glass jars. So you can take one which is of 100 ml, this cylindrical jars you can take, and for testing the temperature purpose we will be using the thermometer, in which we are having the temperature ranging from 0 to 100, 200, 300, like that it is there. So this is the range between 0 to 20 we should be seeing the temperature. Okay. Then we are having the hydrometers. So we can check the hydrometers here. We are having 3 types of hydrometers. First one is 700 to 750. This hydrometer will be used for petroleum analysis. And 750 to 800, this one will be used for diesel and the kerosene. 800 to 850, this one will be used for diesel. Okay, so you can see the ISI marks also. IS 3104, this is Indian standard. On this basis this is prepared. These hydrometers will be looking like this. So this hydrometer you can see. So this one is 0.7 and 0.7 grams per centimeters cube. Okay, so here it is written that density hydrometer from 700 to 750 grams per ml. It should be measured at 15 degrees, used for petrol identification. Okay, then you can see this one. Here on this you are having the 0, 10, 20, 30, 40. Okay, this one is one type. This one is the second one. So here you, for this one you have seen from 700 to 750. So here 700 to 50. So continuation of that you are having this one 50 to again 00. That is 700 to 800. 750 to 800. So this is the density of this. You can, it is written here on this 750 to 800. Clear? So this is one hydrometer, and the third one, last one, is 800 to 850. Okay, this is 800 to 850. You can see it here, 800 to 850. 15 degrees used for petroleum products. Okay, so the complete structure, at the bottom you will be seeing the lead balls. This is the complete cylinder. This is how it will look like. Okay, this one we will put it inside this like this. We will dip it inside like this. We will dip, so it will float. So how it will happen, I will show you now. So for this purpose I need to pour the petroleum products in 3 of these cylinders. Okay, so let's do that. So this one a little, so fill only half. If required we will fill it again. This also half. It is highly volatile, students, so we have to not keep it longer outside. So this one I kept half. Close the lid. immediately. The second one. So you can see the consistency of the third one which I have poured in it. It is dense and it is very thick. Okay, now let's keep. So as this one is very dense, by viewing itself, by visibility only, you can observe that this one is very dense, this one is very lighter, and this one is in medium range. So one which is very dense, we can use the hydrometer which is of between 800 to 850. So you can compare this. So one thing you can do, you can swirl it and you can keep it inside. Okay, this one we have kept, and the this first one is little denser. This one is very light, and this one is between these two. Between these two, this one is there. So I will give a hydrometer which is between 750 to 800. So I will keep it in this. A slight difference is there, but it is not touching to the surface. Okay, so I have filled it. So I guess I need to add some more fuel in this of this type, so that I can make it floating to the upper side. So it has come up. The dense, the gap between the surface and it has increased. Then the third one. So this is the third one. This is a very light, denser in nature. So I am using the hydrometer which is between 700 to 750. Okay, this one I'm using for this. So there is a small gap, so I need to increase it. That means if I pour few more petrol in this, so then that will come up, then I can check it accurately. Clear? And the temperature of these fuels, so like this, three of them I have kept inside. For this also there is very small gap. I will increase the fuel in this. Okay, so that's a good way to test it now. So three of them I have filled with the fuels, and then I kept hydrometers in them. See closer from this point of view. Okay, let's see what is the density of this one. $90. Okay, $50, $60, $70, $80, $90, and this is between 7 and 8. That means it is from 700, right? 0.791. So the density of this one is 0.791, the liquid which is given here. So you can note it down, 0.791. And for this, if you see temperature, let's check the temperature now. So you can check the temperature here. It is lying around 20 degrees. Okay, then let's put it in another one. So whatever the temperature, you can do the calculations later, you can change it. Okay, so let's see this one density. This one is lying near 41. Okay, so 41 of what? 0.7, 0.7. That means 0.741 is the density of this particular fuel what we have taken in this. So probably it is petrol, but this one which is lying between 0.97, 91, it is not petrol, it is adulterated, or it could be the kerosene, but the color is not of kerosene. Okay, it is dyed in the petrol color. What is the kerosene color? It is colorless basically. If it is a PDS kerosene, then the blue color will be added, but it is nor in blue color nor it is colorless, it is in the yellowish color. That means it is adulterated. 0.791 it is there. So coming to this one, so if you see the density of this, it is lying near between 36 of what? 8 and 8, 0.836. So you can check the density of the diesel. So this one is matching with the density of the diesel. So this is how we do the density examination of the petroleum products by using the samples which we get it from the petrol bunks, and this is how we get the results. So you can note it down this results as part of your practical, as you are not having time for doing the practicals and many students are there. So I guess it will be useful for you. Thank you everyone.